Yeah, recording. So what I wanted to talk about was when we're introducing the new SLIs, we'll allow people to set their own target durations for requests. But we don't want to, we don't want what we have now where everything that is less than 5 seconds is okay. There needs to be a good reason to set a 5-second threshold on an endpoint. And I'm trying to come up with what kind of endpoints this is okay for. So far, the one thing I thought of is simple. There needs to be a reason to do it. It needs to be sometimes slow, and we need to be able to explain why that is, and that there's no real thing that we can do about it. One example in my mind is GraphQL. If somebody builds a massive query, that could be okay. There needs to be other things that we monitor there, but the request itself could take up to 5 seconds, not much longer though, but yeah, that might be acceptable.
Well, I mean, with GraphQL, it's kind of arbitrary, right? Because
yeah, because people fill the request with whatever they want. We should just there we will probably define other things. We will the queries that we build for our front end will need to meet different standards, and we will I saw Paul was working on ways of identifying those with operation name and that kind of stuff, and we will probably set different.
Yeah, I think let's ignore GraphQL for now, because I think there's just a lot of questions around that don't really apply to any other endpoint. So yeah, let's ignore that one. Okay, so for increasing a duration threshold, there should be a solid reasoning as to why a duration should be higher than 1 second.
Yeah, I think for example the search controller endpoints that we're using Elastic or something.
Yeah,
are those okay? We know that those don't spend time on the CPU, so they're not really hindering other threads in the same process doing stuff, and we're probably fine with Elastic doing work there.
You could say the same for the database in GitLab then, right? If it's spending all its time in a long query, is that okay? I mean, practically no, because there's also a reason to say no to that, which is that on the database side, we have a connection pool that has a limited number of connections available, and we don't want to saturate that connection pool because we've got one process that's hogging it for a long time because it's taking a long time on a particular query. So I realize that practically the answer is no there. I'm just saying hypothetically, it sounds like that would equally apply to the database and to GitLab and to Redis for that matter, although we wouldn't be spending over 5 seconds in Redis anyway.
Yeah, exactly. So what do we define as what are
the requests that we have to change this, or what are the problem ones? I guess that's another way of looking at it. Can we pick out something in common from those?
One of those things that came up was the counts control, the counts search controller count method.
Yes, that's the counts when you do a search, but they're loaded asynchronously. So from a user's perspective,
so then the product rightfully says we don't really care that that's slow because the user already has their results. They can start looking at stuff, and maybe they want to dig further, and then the counts are handy. So it's okay that those are a bit slower.
Okay, so if I do this search, then those counts loaded asynchronously, but I was able to go click on this, and then they'll probably load asynchronously again, or maybe they're cached when I change tabs. So yeah, you can sort of just about see them loading there. Obviously, in this case, they're fast, but if they were over 5 seconds, I think that's still bad. Right? Because
over 5 seconds, that's
5 seconds is the threshold.
Yeah. So over 5 seconds is always bad because that's just way too expensive. Just the Puma thing alone. But how do we at some point we're going to put this out and people are going to like, what's to stop people from saying, no, everything's fine in 5 seconds, like the way it is now?
Yeah, so is that the main example we have now?
That's the one that's the first group that asked for it, but like everybody, one of the questions that came up is like, you've set the target for everybody to be 1 second, but there's no way to change that right now. So we're building a way to change that, but we want to keep that under control. So I don't know which endpoints will want this. There's also the problematic thing of the SLO that doesn't apply to their budgets, but everybody's only looking at their budgets and not the service availability stuff.
So
wait, let me load something in Kibana. It's going to take a while, and then I'll show my screen.
We've added the ability to make the custom thresholds. To make the custom thresholds per endpoint, but we're saying, when do we have to use that?
Yeah, like it's very easy. It's very easy for us to say we're going, like for us to say like we're going to tighten up the threshold on that Git request thing because it needs to be fast. It's Git authentication. People don't want to wait for that, and it's already fast. It's already meeting SLO, so we just set that, and that's fine.
Yes, it's free. It's not hard politically to do that.
Yeah, but the other way around is more difficult, and I'm trying to come up with a set of rules or a set of something.
So yeah, I think I would be tempted to say we don't come up with a set of rules now. We just take these on a case-by-case basis. So for instance, for the search control accounts, we just say, okay, we're going to do that. We're going to try it out. We might move this back. We might tweak what the slow threshold is, but we're gonna do that for now. Let's see what happens. And then if we get more requests, we can just say we will approve them or not. And then once we've got a few, we can say, is there something in common with these? Do we think all these are valid? Like, I think it's hard to come up with a rule when we don't have examples.
The thing is, I'm trying to load the Kibana query for this, but the thing is, not that many requests need more than a second. Like if we look at the 99.8 percentile duration and the 99.5 percentile duration, which is what we use for our SLOs, most of the endpoints are fine, like barring some outliers, but that's like their budgets themselves are kind of using a 99.95 percentile duration, if you know what I mean.
Mm-hmm.
Let's see if I can fix this by loading a little bit less. Hi, Matt.
Hello, good morning. Good evening for you.
Yeah, we're just waiting for Bob to get something to load.
I'm trying to load a Kibana thing, and there it is. So here's a bunch of percentile durations for an endpoint, the most popular ones on top, and then we can sort this because it's loaded to the slowest one. So this is what we use as an SLO, the 99.8 percentile, and these are the things that would require like a higher threshold to meet them. I don't know if any would apply. Like at the first sight, not. But
well, I mean, yeah. So my inclination would be to say, to like lazily evaluate it, basically, to say like, okay, you stage groups go fix this or make a case to us as to why this should have a 5-second threshold instead of I mean, in some of these, the top few wouldn't actually
Help.
Yeah, with a 5-second threshold. But like, okay, you make a case to us why this should have a 5-second threshold. Once we've got a few of those, then we say, okay, this is the rubric we're using for deciding, but otherwise we just have to decide on a case-by-case basis at the start. Like, I think we might be going too early with the idea of like coming up with a rule for this when we don't know what people are going to ask for and we don't know why.
Yeah.
Like, because someone can make, we can make a rule based on what we know now, and someone can make a perfectly good case for something that doesn't match that rule, but it's still valid. Like we still decide.
Yeah, but then we'd know.
Yeah. So like, why don't we just let them do that? Like let them make the case in the first place.
Yeah.
Until we have a way of making a rule, but hopefully we don't need a way of making a rule because we only need to do a few endpoints.
Yeah, if we only need to do it for 3. And
Yeah, well, even if we needed to do it for 20, if we do it for 20 and then say we're not doing any more, do we need a rule?
Or we need the way forward. Like if we set it for 20, can we link it to an issue like we need to approve this still, but it's a known offender?
Yeah, I mean, I think maybe for some of them that might not be the case. I'm just trying to have a look there and see if that's a good example.
This query is linked from
maybe the post to artifacts might be a good example. Like that's not an interactive command anyway. Like it's run by CI, and it will have higher tail latencies because it's pushing a lot of binary data. I guess would be potential case for that one.
Yeah, that's one of the things I mentioned as well.
Yeah.
We're not in control of the completion duration. Generally, we've been using as kind of exceptional conditions for AppDex, which seems related to the problem you're talking about.
Yeah, that's excellent stuff. And then in the end, that's the whole reason why we want to push the threshold into the application to allow people from product to say like, no, nobody's waiting for this. This can be slow, and like if, as you mentioned, Matt, this is a good example. This is upload to somewhere else, so it's I/O, which means that sometimes the lock will be released anyway because we're waiting.
Yeah, things like the blob controller are interesting to me because we also see, like that will be Gitly, but that will also be highlighting. And like, you can make a case a couple of different ways there, but I think.
Yeah, that's another thing, like CPU bound requests, maybe we should start cataloging these like we did for workers and then send them to separate fleets with other properties. But that's like, yeah, maybe it's.
Oh yeah, it's kind of hard to do that for requests.
Why?
Because, well, just because we don't know what the route is. At the start of the request, we know what the path is, but not the route, right? So we have like those regular expressions in the HA proxy config.
Yeah, and so, why can't we do that with?
Well, it's just not convenient.
Yeah, no, it's not convenient because it's hard to match. Like we already got some Git stuff from.
Yeah,
got it.
Yeah.
Sorry, Matt, you're very quiet. I'm not sure why, but we can hear you. It's just.
Oh. Right, thanks. Yeah, let me fix that. Okay, we'll see if that's better.
Yeah, that's definitely better. Thank you.
Yeah.
Okay, thanks. So, yes, the I forget what I was going to say. I'm sorry. It'll come back to me. Sorry, go ahead.
One more thing that I wanted to drop again, because I think we will need to come up with an answer for this. Like right now, it's very easy to explain the error budgets because something goes well, like it's success rate over failure rate, and like it's easy to explain. Once we turn that into the way we do the general SLA dashboards with minutes where things are good and minutes where things are bad, and then taking averages of that and so on, it becomes hard to explain. But it does allow us to have the separate SLOs like we have for our services. Like for example, we have the 99.8 SLO for AppDex on the web fleet, for example, which currently doesn't apply for error budgets. So Mhm.
Yeah. I don't know. I'm not sure. I mean, we can see what happens, but part of the reason I'm suggesting this is I'm not sure. Like, project events doesn't sound like it should take that long. Like, is that just because the maximum page size is too high, or because we only support offset pagination, or like,
Or an index is missing, or
yeah, like that's.
Could we? So I remembered what I wanted to say earlier is that sometimes there can be interaction effects between requests, and so the individual request isn't necessarily responsible for its own slowness. And one of the ways to kind of identify that is to look at the distribution, like the not exclusively the long tail distribution, like what we have here, but also looking at like like if we added the 50th percentile to this chart as well, we'd be able to differentiate between outliers and a legitimate long tail.
it's going to be angry if I do this, right?
I wonder, yeah. It might just add it to the end.
Yeah,
I think it'll complain that they're not in order.
How to to make a confusing table with Kabbalah. Yeah, I think that's a fair point, and I think that's also a good reason to be like lazy about this and let the stage groups make the case for the threshold, because they can say like, well, we've looked into this endpoint, and actually, it's slow because of it can't, because of other threads in the same process or whatever.
In addition to this is a fantastic display, and I think maybe having in addition to the count column, if we could also have a count that exceeded whatever the threshold we're talking about is, like 5 seconds. That would kind of give an.
I can add that, but well, let's.
Yeah, I can't remember how to do that. There is a way to do it.
I because you taught me that, I can do it. I've done it for. It's not. We need to.
So you need to do the custom thing.
Yeah, but I need to select something that.
I think. Yeah.
Of doesn't duration.
Yeah, it doesn't really matter.
No, I think I have there. I have one of them. So, and now I need to type in a tiny thing. If it's bigger than, bigger than 1.
Oh, okay, do 1, yeah.
Because that's where like we want to, have bigger than 1, because that would require them to make a case.
Okay.
And then, what was it?
Ternary, so question mark.
So
then
then
it's bigger than 1, we count 1, otherwise we count 0.
Yeah, great.
And then I probably forgot. This is not going to be a fast thing to look at.
So, yeah.
Change the label too, just for clarity.
Oh, yeah.
Slow count. Yeah. Oh, that's great.
Hopefully, changing the label doesn't recompute that.
Oh, no, it will recompute that. And the problem is as well, like you don't know if the results you're looking at have been refreshed or not. Well, now we know because we added a column.
Yeah.
Sometimes you change something and then.
Because it's a very subtle thing here, just up by the logo.
There you go.
That wasn't too bad, actually.
No.
I don't think there's an easy way to do slow count divided by count without taking this out to another program, but we can sort of eyeball it. So like projects is what, 1 in 4 to 5 that are over the threshold, whereas events is a very low proportion that are over the threshold.
Yeah.
In fact, that seems like, what's that? A 20th? No, a 50th. So yeah, if we picked a slightly lower percentile, we wouldn't have even seen that on here.
So in terms of, go ahead, yeah.
The slightly lower percentile is here already.
Yeah, sorry, I mean, like, because it's a 50th of requests that are over 1 second, if we took the 98th percentile, that would probably be pretty much bang on 1 second.
Yeah, but that's not an SLO. Like that's not.
No, I know. I'm just saying, like, you know, that's the distribution of it is such that, yeah.
Yeah. So So they're probably very slow. Just
so that's a tail, like that's a case where the tail latency is high, but the median latency, and again, you can see the median latency is pretty good. The project one seems more like it would be not exactly a normal distribution, but something a bit with a chunkier tail.
That project events one, the top one there, I mean, it clearly doesn't represent a large, like if we were storing this in terms of how many requests caused a user to be unsatisfied, like kind of the traditional Aptex definition, then this wouldn't be a high value target because there's only 19,000 requests that, out of clearly over 1 million requests summed across all these endpoints. But that outlier is outrageous, 15 seconds.
Yeah, that's a database timeout, I'm sure, like because the statement timeout is 15 seconds. So yeah.
So it's a thing that times out very often, but that
Which is why I was wondering about the offset pagination as well.
And this also includes errors. Like I'm not filtering those out here. So
okay.
Forgot about that.
Yeah. Status, yeah. Oh, I see. Yeah. I would have done it the other way, so I got confused for a second. Doesn't matter, it's fine. Okay, so what else have we got here? So again, like the Pages API again is even more extreme than that because it's got 20,000 out of 4 million. And it's 99.5 is in fact below 1 second anyway.
Ooh, those are the API calls from GitLab Pages to GitLab API, right?
Yeah, but I think that needs to be fast because that represents a request to the GitLab page.
Events is gone now from the.
Oh, perfect. Well, there we go. We solved one.
We're still spending time on that. Yeah, those are all errors.
Yeah.
Oh no.
Yeah, well, that's the thing, right? Like, that's why it's sort of it's easy to go round and round with this because, like, if the errors are slow. Yeah, but then we end up ignoring those. Like that's almost worse.
We aren't ignoring those. We're just talking about the Aptex SLI here now. It's like the errors are also an SLI, so that's going to contribute there, wherever.
Yeah, no, fair enough.
Yeah. Traditionally, Aptex includes error and slowness, but we don't handle it that way at GitLab. We separate those two. So it makes sense to do.
Generally, like what I found in one of the interesting talks that Andrew linked is it's a single SLI. That's like it's just a single SLI, and you score well or not well. And well is it's successful and fast.
Yes.
Yeah.
Yes, that's the norm in my experience, and we do it differently here. I'm not sure what I can rationalize why it's valuable to separate errors from non-error slow events, but this is the only place I've worked that separates those two effects.
Events are still there, but it's 99.95 has changed. It's like fifth down.
Were we looking?
Yes.
It's fifth on the top.
Yep, right there.
Yeah,
it's 99.95 was like 15 seconds when we looked before. I don't know how that much changed that much. Oh, because of remove the timeout.
Because we got rid of the
timeout. Everything that erred because of a timeout is no longer there.
But the basic proportion didn't really change that much, even though the high percentile did. It was still around about 20,000 out of around about 1 million.
So this makes me wonder if there's like maybe specific projects that have a lot of events, like you were talking about pagination earlier. That seems really possible.
Or something that's looping through the lost pages or something like that, and it's an offset pagination. Something.
So anyway, that's why I would like to push this onto the stage group teams at first, so they can like look at each endpoint that they own and say like, okay, is this.
And what would trigger you to say no?
Well, so for something like the events one, I would be tempted to say no, because it is actually pretty close to meeting this SLI. Like if you look at the distribution, like it's pretty close.
It's not.
No, I mean, it's not, but I mean, like if you get to 98%, it's still fine. So like it's only at the tail where it's going up, whereas something like the projects API is a full like quarter of the requests are over the threshold. So like,
but wait, the 90, this is the SLI for the SLO for API, which this is handling. And the duration there, so the 99.5th percentile is 2 seconds. So that would still require an increase from 1 second, the default, to 5.
No, all I'm saying is, like, I think it's easier for the development team to get a handle on the events API because, what is that? I can't do math in my head. 2% of requests are exceeding it, as opposed to API projects, which is the top row, where 25% of requests are exceeding it. Like that's, I don't think that's a sort of theoretical argument. I think that's just a practical argument that like, if you have 25% of requests for, and we know that the projects API will support a bunch of different options, same with the group projects one, where like, you know, you can sort it this way, you can include these fields, you can exclude, it's basically like a proto GraphQL API where, you know, there are plenty of different response types.
Okay, like that.
That's very different to the project events one, where it's already 2%. Like pages is even closer, because that's what 20,000 out of 4 million. So that's, oh well, it's actually 99.95 is fine. It's only at 99.8 that it gets bad. I think those ones are the ones I would be tempted to say like we won't increase the threshold for, because you're already.
Yeah, so this one is interesting, because we would say 1 second is fine because this runs on API and it's meeting aptex or aptex, but the group will see this one, which is like, yeah, we should set it to 5 and then our error budget will be green.
Yeah, but I think as well, there's a case that's more of an interactive request, even though it's an API request, because this is made by GitLab pages when you visit a GitLab page, and because those are static pages, they shouldn't be taking 5 seconds. So there's also a
this happens before we start serving the pages page.
Yeah, I think
right?
there's also a theoretical basis for that one, that like, you know, this is because of the usage pattern, and like maybe the diffs batch one is kind of in between, because I think that's triggered when you scroll on the diffs page on the merge requests. So, you know, maybe there's a little bit more tolerance than for the first page load, but it's still interactive. But yeah, my temptation is still to just start by saying, like, you know, make a case, like make the stage group make a case. We can say what like exceptions we've added before and why, but also look at.
Yeah, and then also make a call, like saying this is okay or this is okay for now. Like,
yeah, it'd be nice to make a Kibana histogram they can plug in their caller ID into and show what the distribution. I mean, the Kibana histograms aren't very good though, but like if they can show what the distribution of response times is as well, because like you can see from the summary statistics we have here, again, projects 25% are exceeding that threshold. You know, the pages one, it's 1% that are exceeding, or just over 1%. Sorry, not pages, that's tags. Pages is about 0.5% that are exceeding the threshold. Those are very different, like going to be very different histograms for those, and there'll be very different paths to getting them to meet that threshold if the stage group can't do that.
Okay.
The other thing is, this might be going on a tangent a bit. For what I remember, it almost doesn't matter if every endpoint for the stage group meets the thresholds, as long as
the most popular ones do.
Yeah, as long as overall. Yeah, exactly. Like if you have a request that an endpoint that has 1 million requests per day and one that has 10,000 requests per day. No, that's a bad example. That's not the right proportions, but you get the idea. If you have one that completely dominates your request count, and that is always fast, then it almost doesn't matter what your other request endpoints do, because when you aggregate it up by stage group, you will probably still meet the threshold.
Yeah, because most of your things are fast. Likewise, like if you have a thing that has 1 million requests, and just because it has so many requests, it has 10,000 slow ones, that's still pretty good. But if you have one below that has 5,000 slow ones, but only 10,000 requests, then
that's clearly just not a fast endpoint. And like either we really need to fix it, or it's basically unfixable because it's doing an inherently slow operation.
Okay, case by case basis, and I'm going to try to summarize a bit of what we said here. With the,
I mean, I do think it's really important to give some guidance about how to prioritize these, because if we present a case where you need to have a certain percentage of endpoints per stage group that meets the target response time, that gives a huge incentive to prioritize whatever's easiest to improve, rather than improving the end user experience. And
yes,
the whole goal of scoring based on AppDex is to improve the end user experience. So prioritizing, for example, a high throughput API endpoint where end users aren't actually waiting for the response will improve the stage group's score without actually improving the user experience. So I think we should explicitly state that the goal here is to improve, things that end users will perceive as being faster.
Yeah, and product manager are in a way better place to make a call. Like nobody's waiting for Get API projects to complete because it's automations and I don't know what. Yeah.
Yeah, that example for the GitLab Pages API call is, I think, fantastic, because kind of the initial gut reaction is going to be, well, API calls are generally, not a thing that humans are waiting on, but in this case, it certainly is. I mean, it makes a good case study, is all I'm saying.
This has been a great discussion. Thank you both.
Yeah, I think it's good to get people working on this. I just don't want to. I don't know. The sense I get is that people are asking for more.
I think you're saying we shouldn't be too prescriptive, right? We should.
Well, I don't think we should be too prescriptive too early. Yeah, I think we should. Yeah.
Yeah, and I guess all I'm saying is that I completely agree with that, and I think that it's very helpful to bring a couple of examples with us.
Yeah, no, for sure.
Kind of get the conversation going.
I think, yeah, the examples we discussed there are probably reasonable cases to start with. Like,
I'm going to
post is like probably not that important to end user experience.
I'm going to bring up the 3 examples. I think I'm going to bring them up in the issue for now, but I don't know how I translate that to documentation. But the 3 examples that I take away are like the internal pages one. That should probably have a tighter threshold because people are actually waiting for it. And
it certainly shouldn't have a looser threshold.
Yeah.
Yeah.
There's the project's endpoint that has 1 million ways of calling it, and some of them are just more work to do, and therefore it's slower, and there's not a lot we can do about that. And then there's the artifacts upload thing, which uploads a thing, which is moving data around. It's going to be slow and also not a lot we can do about it, but also not very bad because it's not happening on the, like it's not occupying the worker all the time while it's doing that, I think.
Yeah, that sounds good to me. And those are probably the easier cases that we discussed, but it's good to start with the easier ones and work up to the harder ones.
Well, if we can, we have 3 cases there. If we can correlate requests that we get from stage groups to one of these, like there was some stuff that I worked on with the people from registry as well, where the requests were slow, but yeah, they were sending 3 gigabytes worth of data across the wire. It's not going to be done in a second. So if we can make a correlation to one of those things, and there might be more that we will discover, then we'll learn. Anybody else want to bring up something more?
Let me just quickly share this stuff about the rate limiting Redis instance. So we're doing another functional partition of Redis. So we currently store rate limiting data for 2 different ways we do rate limiting. So one is the third-party rack attack library, which happens on the request level before the request is like even passed to Rails. And then there is what we call application rate limiting, which is inside a request. We can say, like, if you're doing something expensive like an export, each user can only do 1 export per period. And so we have two things there. We're going to use this new Redis for both of them. Like the cache, it can be configured as an LRU because it's rate limiting information. It's generally very short-lived. So most of what I've been doing on this so far is adding the ability for the application to configure that, which has mostly been about learning about how this already works. So
that's the adding a class bit.
Yeah, so we add a class. So I'm just going to share this. So this is the current state of this file. So this is config/readme.md. So it's docs, but it's not actually on a doc site. So this is mainly used, I think, for source installs. I'm not 100% sure what the audience is, but we have very detailed documentation on each Redis instance. And there's some slightly confusing parts, like Redis cache defaults to port 6380 on localhost, Redis queues defaults to 6381, and Redis shared state defaults to 6382. So this is only if you have no configuration files at all. So this is apparently supporting some very legacy use case. What I've tried to do here is simplify this. So when we add a new one, we don't have to copy and paste all of that stuff. And we can hopefully avoid making the many copy and paste errors that I made when I was working on this. So we just say, like, you have an instance, it's called this, it's going to look in this environment variable based on this name, or it's going to look in this file, or if it's available, it's going to look in this file. If there's no URL, it's going to use localhost and this port is the basic idea. So these are hard-coded in the application. And previously, the trace chunks didn't have a default at all. So if there was no Redis configuration, the trace chunks Redis instance wouldn't work, which I think is fine because that's optional. But if I have no idea if this is a case we need to support or not, but if it is a case we need to support for self-managed instances, then we do need that for the rate limiting one, because it's much more likely that rate limiting is turned on trace chunks, because trace chunks needs a feature flag and rate limiting doesn't. And when we move sessions, that'll be even more important, because literally every GitLab instance uses sessions. So there's no way we can get away without that. So that's the basic idea.
Trace chunks already does the clever fallback to what it used to be, right? So,
yes, but it doesn't fall back with the port, because, I mean, it's hard to even notice that's a thing. Like, you need to literally have no configuration files whatsoever, which is like unusual. I don't even know how you would have Redis running on those ports in that case, but apparently it's a thing. The other thing is, I noticed, and this is just a weird thing, but I figured it was worth cleaning up. So in the GDK, the GitLab development kit, we set different Redis databases for development and test for each instance. So they act as isolated instances. And that's helpful because, A, if you have a key clash, although you shouldn't, but you could have a key clash potentially, but also B, if before, like, we just use the same instance for the same database, sorry, for
you're logged out every time you run the tests.
Yeah, development and tests. So if you run the tests and they clear Redis, that logs you out, that deletes all your sidekick queues, that does everything. And these database numbers in these configuration files, which are, again, I'm not sure how useful they are, were different to the ones we use for the GDK, but I figure as they're example files, I can just make those match up. So basically, yeah. I'm just trying to make that a little bit easier in future, because this isn't hard adding a new instance. It's just tedious because there's a bunch of like little paper cuts like this that will trip you up, and it's mostly pretty rote. But as we're going to be asking the memory team to add the one for sessions, it seemed like a good time to take a bit of time to do that.
Jakob already did a lot of work when he added the trace chunks one, like to make it a little bit more manageable code-wise to do that, but apparently we missed the port bit.
Yeah, well, exactly. So this is the thing. Like, yeah, basically, I submitted this MR to Jakob, and I was like, "This looks pretty good to me." And Jakob was like, "Well, you've copied and pasted the wrong thing here. You copied and pasted the wrong thing here. This port, comes from here." And I was like, "Okay, right. Let me go fix that." And then he spotted a bunch more things, and then I was like, "Okay, let me go fix that." And then he was off today, so I was like, "Okay, let me take a step back here instead of playing whack-a-mole and see what I can actually learn, because this is clearly not as straightforward as I thought, and it's not going to be straightforward for the next person to do it." So. That's where I am with that. And then well, I also have that thing with the feature categories and the sidekick ones that I need to figure out where.
Yeah,
so
back into the client middleware.
Just the context, Matt. So Sidekick has a client middleware and a server middleware. So client middleware is run when you schedule a job, and server middleware is run when the Sidekick worker process picks up the job. And previously, I had added something to the client middleware for feature categories so that we get the correct feature category in the logs, but then that didn't work for metrics. So when I was working on the metrics one, I tested with cases that I thought were reasonably exhaustive, and I figured that I only needed the server middleware. Recently, I found out that's wrong because the logging actually isn't a middleware and it happens around the middleware. So the middleware has no effect on the logging code. So now I'm like going back to like, do I need to have this in two places? But I deliberately deleted the client middleware because it was causing problems with the metrics. So I'm having difficulty getting the logs and the metrics to line up, and Bob's gonna have to review that when I get to it. But at the moment, I would say the metrics are right and the logs are not what I want, which is the better way round, because the logs are more transient, and also the logs are wrong in a way that makes them higher cardinality, which is okay for logs, but wouldn't be okay for metrics. So when I say wrong, I mean, there's two reasonable positions you could choose. It just happens that they don't line up. So yeah, I need to fix that, but I don't really have anything to demo there because I haven't figured out how to do it. Anybody else?
For the transitional state, when we begin to roll out the oh my gosh, I'm blanking out. The topic we were just talking about.
The Redis rate limiting.
What's its name? Yes, the rate limiting. Thanks. I'm assuming. So I wanted to check my assumptions here. I'm assuming that we're not going to make any attempt to transfer state information from for the current state of rate limiting when we roll this out. We'll just start with a clean slate, so everyone's consumption rate goes back to zero at the moment of rollout.
I haven't 100% decided on that, but I looked at
It's vastly simpler that way, and I felt like we could get away with that simplicity.
Yeah,
but,
no,
yeah,
Rakitech stores data for a minute, I think. Yeah. So it's fairly. I mean, the feature flag is
since most of the time we're not. Yeah. Okay. Yeah.
So like you're really like if you're using a feature flag for that, like you'd really be struggling to notice the difference either way. I think the longest interval we have for an application rate limit is on the order of single-digit minutes. So with those, I think the current plan, which I need to discuss with Craig because I haven't gone around to writing it up, is that we won't attempt to transfer data or do multi-writes or multi-reads, but we will feature flag them so that we don't switch them both over at the same time. So like we can switch just rack attack or just the application rate limiting.
Sure. Okay.
But those will both be all or nothing. Yeah. So like because like you said, it's a lot of work. It's very
simple to reason about. Yeah.
Yeah, it's a lot of work to try and cut that data over, which we will need to do for sessions.
Yes.
Yes. And that will probably need to be a multi-read, multi-write.
Yes.
And also potentially creating the sessions instance based on a backup from, well, I don't even know. I haven't thought about that far.
I guess all I was getting at is I feel like we can get away with that this time because
exactly. If we don't have to do it now, don't do it.
Yes, exactly. Because we're not under attack most of the time. We're not under an abusive workload most of the time, and we're not going to roll this out while we're under a massive attack. So we're giving someone a free pass for a few minutes to double the number of requests they're making to some endpoint that would otherwise be limited, and that seems okay.
Yeah.
If we had the longer durations on those thresholds like Jarvis suggesting, would we need to migrate then, or would that still be fine? Like then it's like requests an hour, if I remember correctly.
Oh yeah.
We're not there, so we don't need to worry about it. But
yeah, that's a great question though. I guess I would still because it seems like a complex scenario that would be easy to get wrong. I guess I would probably still lean towards not bothering with the migration this time because we can get away with it.
Yeah, I would.
If we were talking about a rate per hour, if it was a rate per day, then I'd be a little bit more hesitant about skipping that step.
Yeah, I would go back to Matt's point from earlier about like we're not under attack most of the time, and we wouldn't do it when we're under attack. So we'd probably just do that at a quiet period, like not even a quiet compared to under attack, just a quiet, low traffic period in general. And hopefully we do that in a quiet hour, so that by the time the hour's up, we're good. Yeah, I think for this one, it's just so much simpler to implement, to roll out, to everything. But there's far fewer failure modes this way, and it fails open, which is also useful for users.
Yes, absolutely.
Yeah, I think thanks for bringing that up, Matt. I do need to actually write that up for grade, because that's what I've been thinking about and got around to writing down.
Anything more?
I'm not awake enough to talk about the things that are kind of top of mind right now. So maybe next time. There's been a lot of I think there's been some very interesting discussion around Gitli's fork lock, or rather the Go standard library fork lock, and how that interacts with Gitli's child process caches like the cat file cache. But again, I haven't had my tea sink in yet, so I'm not quite alert enough to have a discussion about it. But maybe just kind of a toe dip, if that's okay. So there's as I'm sure you both know, we've got this kind of fairly complex system of maintaining a pool of child processes, these Git cat file processes that Gitli will preserve rather than allowing them to be purely ephemeral processes that satisfy one gRPC call. We'll keep them around in anticipation of potentially having another request for the same repository that's compatible with this process. And this saves us roughly about 50% of the time we don't have to fork a new process. And there's been some very I think healthy discussion about whether or not this historical decision from a few years ago is still the right choice in terms of the complexity versus benefit trade-offs. One of the things, so that's one discussion, and I feel like that, and there's a separate discussion that I feel like is about to converge, where as part of incident response follow-up, we've been Igor and I and a few others have been kind of intermittently over the last week digging into some concrete examples of long tail response time that ultimately seemed to be like for the find commit endpoint was one example. There were a few other endpoints that initially we were investigating separately, and one of the common attributes that we've uncovered is A, burst of CPU contention, and B, it's a little hard to talk about this without a visual aid, but let me just describe it in broad strokes. There are two layers of scheduling that matter in this context. What I'm working up to is the a given Go process, like a single Gitli process, has a single global mutex that guards forking child processes. In addition to that, Giddily has an additional layer that what's it called, spawn token, that imposes an additional rate limit. And I'm not entirely sure what how beneficial that is, because there is already this underlying fork limit. But what I want to talk about is this global mutex. It's a reader writer lock. So it's effectively a semaphore that guards whether or not the given Go process, Giddily in this case, is allowed to create a child process. So it turns out that that in at least some of the cases, we're not sure what the percentage is, but in at least some traced examples, we find that there are many tens of milliseconds of waiting for that lock to be acquired. Which implies that either there's a burst of demand for that lock, where there are many each Giddily process has 32 OS threads that many Go routines can be scheduled onto. I started to talk about this earlier, but there are two schedulers that matter. One is the kernel scheduler to see which tasks get scheduled on CPU. And the other is the Go runtime scheduler that will schedule Go routines to run on these long-lived OS threads, the Ps in Go's kind of scheduler model. So effectively, Go can say, okay, Go routine A that wants to that perhaps wants to acquire this fork lock, you are allowed to start running on this this designated OS thread. Then kernel will schedule that OS thread, which has entered the runnable state from kernel's perspective, to run on a CPU, maybe sometime. Here's the catch. By default, Go runtime is going to allocate 32 OS threads on a machine that's got 32 cores. But we know that on our Giddily boxes, the Git child processes consume a significant percentage of CPU time, sometimes often more than Giddily itself. And so there's often, when we have CPU connection at the host level, at the kernel level, those OS threads that Giddily, that the Go runtime is managing for Giddily, they don't actually get access to CPU as often as they think they do. They're contending for CPU at the kernel scheduler level with all of the child processes that they're trying to manage. We're not sure how big of a deal this is, but it has to have some influence. Whether it's a major influence or a minor influence is an open question. But it has to have some degree of influence, and it may, by influence I mean the question we're trying to answer right now is what is influencing the duration of that lock contention for this fork lock. And there are kind of two, again, in broad strokes, there are kind of two angles that can kind of influence it. One of them is, was there a burst of requests for fork locks where many Go routines want to fork a child process at roughly the same time? Or do we have a stable rate of incoming requests for that lock, but the lock duration has increased? So there are a few ways we can kind of test, we can differentiate between those two cases. In the latter case, where the lock duration is longer than usual, this is one of the ways that CPU contention that we were talking about a couple minutes ago may be coming into play. So this is very much an open research topic, and we're kind of putting time into it as time allows. It's not like a primary focus for anyone. I think I have a couple of ideas for next steps, and I know Igor has a couple of ideas for next steps as well. And I think we haven't talked in a couple of days about it, but I feel like this is a worthwhile thing to look into. I'm not leading up to anything, by the way. I should have said that to start with. This is just kind of rambling about an interesting problem. I think this has relevance in terms of kind of the long-term planning, because two reasons. One, it may the outcome of this analysis of this essentially lock contention over the ability to create child processes has a meaningful impact on whether or not on the discussion of whether or not having a cached pool of child processes like the gitcat file cache is or is not a good design choice still, because we know that we're cutting in half the number of times we want to do those forks. I guess there are a few ways to kind of address that if we don't, if for any reason we significantly increase the demand for forking child process, like for example, removing the Git file cache. There are a couple of ways we can address that. The kind of conceptually simplest one being spread the work across more Gitly processes, which in my view means spread the repos across more Gitly nodes. There are a few trade-offs let me leave that aside. I guess the other thing I wanted to mention is, so the question about the benefit of having a pool of cached child processes that are potentially reusable is I think influenced by by what we uncover here with the fork lock contention. And the other piece is being aware of the cause of the contention. If it turns out, for example, to be contention at the CPU scheduling level, then we can do something about that with no code change and without having to move repos around by, for example, explicitly telling the Go runtime to continue to provision 32 OS threads, but resizing the Gitly hosts to have, say, 50% or 100% more CPUs available, so that there's less contention at the kernel's scheduler level. Does that make sense? Without reducing capacity in terms of schedule and Go routines, because that also could change bottlenecks.
Are the number of child processes limited somehow?
Oh, that's a great question. We're not running in. Yes, there is a hard limit on the number of child processes, but we're not anywhere close to it. It's more the creation rate that's. Go ahead.
Yeah, I've seen a couple of issues around this, so forgive me if I'm covering something. So I did see one where Patrick was mentioning that we always spawn 2 processes as part of the cache, even in the cases where we only need to spawn 1. And then a refactor he did to try and lay the groundwork to remove that ended up with a Go routine leak. So clearly the code itself is quite hard to reason about and modify safely, which is also, I guess, a challenging aspect of it.
Yes, I think I also read about that, although probably not in a great deal of detail. Patrick, I think, was one of the people that was saying that this file cache is quite complex, that it adds a significant burden, maintenance burden to the code because it's fairly complex. And I love that we're talking about, considering the trade-offs of jettisoning a complex piece of code if it's not providing enough value to justify it. And I kind of suspect that we may know more now than when we added that code in terms of like the contention. I still want to personally, I still want to understand the interactions between our Gitly specific spawn token mechanism versus the fork lock, which I suspect is kind of an implicit additional concurrency limiting factor.
Yeah, I think it would also be interesting to see why we added that. Like, when the cat file cache was added, what would we see? Like we were using I'm almost certain we were using completely different infrastructure, possibly on a completely different cloud provider at the time we introduced this. Like it's
and the Go runtime changes over time as well. I mean, although so it may be obsolete at this point.
And we can't really tell.
Yeah, exactly.
At the moment, we can't tell.
So in terms of like next steps, I feel like a discrete helpful question to answer is differentiating between those two cases of, do we have a spike in demand for this lock, or does the lock duration increase when we have one of these events where there's significant contention and it affects the gRPC response time. I kind of had that in the back of my mind when we were looking at earlier in this talk, when we were looking at the response time distribution on a per endpoint basis. That we can have these kind of subtle interaction effects. And this is obviously not the only way that can happen, but because it was kind of, top of mind after looking at it in the last couple of days, it was hard not to think about that in the context of trying to evaluate long tail response times. That's again not leading up to anything. I'm just kind of musing about the topics we've talked about today.
Yeah, no, thanks. That's interesting. I wasn't fully up to date on that. I just knew that I'd seen the words cat and file and cache a lot lately.
Yes. Yeah, I don't think that there's been any explicit connection between these two topics, the log file contention and the cat file cache, but I feel like they're probably exploring different aspects of the same problem space. So yeah, that's the reason I wanted to chat about it.
For sure. No, thank you for talking through that.
That's all I had.
Cool. Well, have a good one, everybody. I'll speak to you soon.
Bye-bye.